Welcome back to my channel. Today let's learn a new topic in periodic table, that is modern periodic law. So first let's go with the statement. The physical and chemical properties of elements are periodic functions of their atomic numbers. So it was Mendeleev, he's called as the father of the periodic table, and in the early 18th century he could only, by then there were only 68 elements which were formed. So keeping his um, periodic table as a standard, and as in when the elements were discovered later, they started getting added on to his periodic table. So that's the reason he's termed as the father of periodic table, because he had already analyzed and he had grouped the elements in proper um, rows and columns. So this is the statement: physical and chemical properties of elements are periodic function of their atomic number. So as you see, when you look at the periodic table, there's always a repetition. So if you look at the colors here, the colors here are defining similarity in their physical and chemical properties. So that's the beauty of periodic table. So now this periodic table is also called as long form of periodic law. So here they are, the periodic table is grouped into vertical columns, as you can observe. If you look at, if you count, there are, starting from here, 1, 2, 3, 4, and so on, and the last one is 18. So the vertical columns, they are called as groups, and the horizontal rows are called as periods. So totally there are 18 groups, that is vertical columns, and there are 7 periods, that is the rows. So there are 7 periods. Okay, and the elements are also placed according to similarity in similarity in their physical and chemical properties. Now if you look at the pink elements, okay, that is the alkali metals: lithium, sodium, potassium, rubidium, cesium, francium. So here these have similarities in periodic, I mean they are periodically, when you arrange these elements, there is similarity in physical and chemical properties. Similarly, when you look at these purple elements, the alkaline earth metals: beryllium, magnesium, calcium, and so on, again there will be similarities in physical and chemical properties. So that's the statement of the modern periodic law. Okay, which states that properties are periodic function of the element. So as in when you arrange the elements in the periodically, they will be having similarity in the properties. So now the elements, okay, they are grouped in, as I already told you, according to the similarities. So but we should also know that the period number corresponds to the highest principal number of the element. Suppose you take the first element, okay, that is, I mean the first period, n1. So in n1 there are maximum of 2 elements. So principal quantum number, as we all know it, the rule is that 2n square rule. Okay, so this we will be learning in the in inorganic chemistry. Okay, and also when you talk about quantum mechanics also, we'll be learning this 2n square rule. So according to 2n square, n stands for principal quantum number. Okay, means which defines um, the number of electrons present in a particular orbit. So now here when we're talking about periodic table, here n refers to the number of, I mean n refers to the principal quantum number, and when you solve this, the answer that you get, that is, let's say 2, 8, 18, 32, right? So as it is 2n square rule. So n is 1. If I substitute n is 1, then I get 2. When I substitute n is 2, I get 8, because 2 square is 4 2s are 8. Then when I substitute n is 3, then I get 18, and n is 4, I get 32. So here also, if you observe students, they are arranged in the same pattern. So if you take the first period, okay, hydrogen and helium. So here how many electrons are there? How many elements are there? There are 2 elements. Okay, now n is 2. So when n is 2, the next is going to be 8 elements. And then again 8 elements. Then again 18 elements, 18 elements, 32, 32. Okay, so the order is 2, 8, 8, 18, 18, 32, and 32. So here you can observe here. The first period contains 2 elements. The second contains 8. The third contains 8. Fourth contains 18 elements. Fifth contain 18. Sixth contain 32. And seventh contain 32. Now here if you observe, one more thing is that the last two rows, okay, the light blue and the light green, these have to be adjusted within 56 and 72. So here the space here, so here in this space are these 14 elements. Okay, but since if these were inserted within the entire periodic table, it would have got elongated. So that's the reason why they are placed separately below the or in the last row. Okay, and why they're separate, why they're placed separately also, there's a reason. So now if we talk about this one, lanthanide series, okay, so here there are 14 elements. Now lanthanides, though they are metals, they are a little different from the other metals which are here, because lanthanides are very heavy metals. If you look at their atomic number, right, they are very very heavy. Okay, the nucleus of these atoms are very heavy, so that's why they are given a separate place at the bottom. Similar, the next one, actinide series. So if you look at the actinide series also, they're again placed at the bottom because these are, though they are metals, they are radioactive metals. Okay, so that's the reason why, how beautifully the modern periodic table is designed in such a way that the periodic table has the same size. Okay, but the extra elements, that is these 14 elements, are placed below the table, so that the periodic table doesn't look elongated. And also one more reason is that these have different properties compared to other metals. As I already told you, lanthanide series, they are heavy metals. They are heavier than the other element metals which are placed above in the table. And the last one is actinides. They are radioactive metals. Okay, so that's the reason why they are placed below. Now if you when we count, students, we should remember that this is 6 and this is 7 group period. So if you count the entire thing, if you count all the elements, there will be totally 32 elements in 6 and 7. 6 and 7, there will be 32 elements. And in one there will be 2. In second period there will be 8. Third period there will be 8. Fourth period there will be 18. And fifth period also there will be 18 elements. Okay, so this is how the periodic table is, elements in periodic table are placed. Now, yeah, as I already told you, 14 elements of lanthanide and actinides are placed separately at the bottom of the periodic table. So already I have told you the reasoning. Okay, so this is all about the modern periodic table. Thank you so much.